Hi, I'm Pooja Singh, and in this video, I will be describing k-means clustering from scratch and also how to use the k-means clustering on digits and images. In this notebook, we start by importing the necessary libraries, including matplotlib.pyplot for visualization and numpy for numerical computation. The matplot library inline magic command ensures that all plots are displayed directly within the notebook. We then process to create the synthetic data for clustering using make underscore blobs from Scikit-learn.dataset. This function generates dataset with 300 samples divided into 4 clusters with a standard deviation of 0.6, ensuring reproducibility with the fixed random seed. The generated data is stored in X, which contain coordinates of the points, and Y underscore true, which contains the true cluster label for evaluation. Now we apply the k-mean algorithm from Scikit-learn.cluster to synthetic dataset, and the algorithm is initialized with 4 clusters trained on the data using fit method. After training, the predict method assigns each data point to nearest cluster, producing the predicted cluster's label stored in y underscore k-means. To visualize the result, we use a scatter plot. Where points are colored according to their assigned cluster labels. The cluster centroids are also displayed as larger black points, providing a clear representation of the clustering outcome. And to better understand k-means process, we implement the algorithm from scratch and custom function find clusters. This function starts with randomly selecting initial centroids and then iteratively assigns points to the nearest centroid and recalculate the centroid as the mean of the assigned points. The process continued until the centroids no longer changes. Using this function, we cluster the synthetic dataset and visualize the result, displaying both the data points and the computed centroids. To determine the optimal number of cluster, we have applied the elbow method, which calculate the inertia or the sum of the square distance of the points to the nearest cluster centroid for different clusters. The inertia values are plotted against the number of clusters with the elbow of the curve indicating the optimal cluster count. Additionally, we evaluate the quality of clustering using silhouette score, which measures how well each point is clustered. A high score indicates better defined cluster. The score are computed for cluster count from 2 to 9 and plotted to identify the optimal number of cluster. Next, we have defined the function to visualize decision boundaries of k-means algorithm. The function generates a grid of points covering the range of the dataset, assigning each grid point to the nearest cluster using the traditional k-mean model. The resulting decision boundaries are visualized as the shaded region overlaid with the data point cluster centroid. This provides a clear illustration of how k-mean divide the data space into distinct regions. Finally, we have visualized the cluster centers learned by k-means algorithm. These centers represent average digit for each cluster and are reshaped back into 8x8 grids for the display. The resulting image gives a clear idea of what each cluster represents in the content of handwritten digits. Thank you.